and welcome to Unapologetically Technical. My name is Jesse Anderson, and this is the show that's different. We go deep, we go all the way down. With me today is my good friend Tyler Akidau. He is the CTO at Redpanda Data. Welcome to the show, Tyler. Would you mind introducing yourself a little bit more?
Thank you, Jesse. Thanks for having me. By way of introduction, I guess I've been a software engineer for a little over a couple decades now. Primarily focused in the stream processing space has been where the bulk of my time has been spent. Started out at a little storage company called Isilon back in Seattle, was there for 5 years-ish. Then I was at Google for about 12 years, and most of my time there was spent on various large-scale data processing projects, starting with MillWheel, heading into Apache Beam and Cloud Dataflow, and having some amount of involvement on MapReduce and Flume, the internal Google Flume. From there, I went to Snowflake, was there for about 5.5 years, again, focused on stream processing, doing what I could to bring stream processing into the Snowflake fold. And then, recently moved to Redpanda as the CTO there. We're a streaming company who's kind of expanding beyond streaming and moving into Agentic AI. And I guess the other bit I should call out is that as part of my journey through streaming at Google, had the opportunity to work with O'Reilly on a couple of blog posts and then a book as well, which was kind of where I've managed to get kind of broader reach with my advocacy for streaming and stream processing topics. And around that time was when I met Jesse. Like we interacted a bunch at the Beam level back in the day. So that's the shortest version of it, at least.
Yeah, it's weird. And I interviewed Francis, if you didn't know that. And so a lot of those stories, a lot of my time around then was when I would say I met this core of people that I've kept up with over the years. And as I look back in life, I think the golden era of that time or of this age is not now. It was right then. We had a golden age right then. It's kind of sad to look back and see that we still don't have it. But you tell me the story about your LinkedIn picture. Of all the LinkedIn pictures I've seen, yours is probably one of the more unique. So tell me that story.
So I love that picture, and it's so out of date at this point. It has my 2 kids in it. They're 14 and 12 now, and there they were like 3 and 1 or something. I don't remember. But it's just we were at so in Japan they have these photo booths. I forget what they're called. It's like purikura or something like that they're called. And you sit in the photo booth and you take these pictures and you get these crazy backgrounds and they can do these crazy effects and like make your pupils look large and you can then go in and manually edit and add these stamps of various things. And for whatever reason, the Nordstrom in Bellevue up here in Seattle had one of these in the women's department. Like this must have been, so this was like 10 years ago or something, 11 years ago. And so we're just like, walking through the Bellevue Mall and we see this and we're like, whoa, we should like take some pictures. And so we just hopped in and we took, we probably hung out there for like half an hour, took a bunch of pictures and, every time you'd go through and be like, all right, what are we going to put on this, pirate hat or, whatever. And that was just the one that I found most delightful. And so I started using it. And then, I haven't been able to come up with something that quite captured the same energy since. And so I've just stuck with it, even though it's completely out of date. But I like it. It's unique. It fully captures like my feeling around parenting, sort of the joy, but like the craziness of it.
As you tell that story, it reminds me of the photo booths that I've done with my kids, where looking back even 10 years later, those are like these core memories for them where we were, being silly in the photo booth. So recommendation, everybody watching, especially if you have young kids, take that time, do those silly photo booth things because you'll see the picture years later. And both of you have these very vivid, very beautiful memories of that.
Yeah, 100%.
So you, as you mentioned, you started your career in Isilon. And as I was going through your resume, I thought, Is that the same Isilon? Because I haven't heard Isilon, the name, in quite a long time. And I think it's the same one. It's a storage company. And it's kind of crazy to think back, but tell me that story. Why did you end up at Isilon?
So I was looking for my first job. I graduated in 2003 from the University of Washington with a bachelor's, and that was like the absolute pit of despair for software engineer hiring after the dot-com burst. It was just so hard to find a job. And so I forget how long, I went many months without any real leads. And I really wanted to get into distributed systems. That was the other thing. And so like Seattle was kind of there's not a burgeoning distributed systems area at the time, let's put it that way. But there was this one little startup called Isilon that was doing distributed storage. And I'd focused on storage, a bunch of like mostly on file systems, but I've been very storage focused during my degree. So I was like, I want to work at this place. And so like I call and call. Eventually did get an interview. I did one phone screen. I don't think I did poorly on it, but I think they were just kind of like, I'm not interested in hiring some kid fresh out of school we know nothing about. And so, I went no further. But I was like, I want to work here. So I kept calling back and be like, well, what about an internship? Like, I ain't got a job anyway. I'm not getting paid. Like, what could I do? And they're like, well, we are hiring this disqualification job. Like they basically, they'd been using one type of disk. They wanted to expand the sizes of their disks, but they, wisely knew that like different hardware, worked better or worse, especially under heavy load. They were using consumer disks for an enterprise product, and so they needed to find a consumer disk that was reliable enough. So what they had done is they'd kind of had a set of different types of disks they were wanting to qualify. Their head of hardware had written up some qualification tests that basically just did a ton of writes and reads to the disks, just exercised the heck out of them, and then did correctness validations. And so they just needed someone to come in, kick off these tests, let them run, gather the results, rotate the disks around, they wanted to kind of swap them around in the bays and things, run the tests, gather all the reports, and share them. It was like $15 an hour. So I was like, I'm in. Came in, I interviewed. I was, grossly overqualified, so they hired me. But it wasn't a hard job either. Like you're swapping disks and then hitting a command and waiting for a few hours. And so then I did a bunch of programming projects for them while I was doing that. And their lead hardware engineer, Jonathan Walton, was happy enough with what I did that by the end of it, he was like, I want to hire this guy. And so I got hired on. I was the first hire in the hardware team. Focused on manufacturing tests and did a few driver level things like a system event log in the motherboard and a kernel panic driver for the motherboard, so that if our motherboards had this ability to like signal you with an interrupt if a memory error was detected. And so they decided they want to just panic the box if that happened, to ensure that we could never make it to disk. Because since it was a distributed system, like the rest of the nodes could, keep functioning, whatever, it'd come back up and you'd go forward. And I worked on like their check disk tool, and it was up to like doing RPC stuff, like building an RPC framework for Python by the time I left for Google. But it was a super cool company, and I do think that like I hadn't been in hardware when I was doing my degree, and so I think getting that foundation of like understanding how the hardware works at that level and how you interface with it, and the importance of, from performance and just everything perspective, of like, this is the reality of it. Plus the reality of like hardware is just janky as can be. Like, you get the hardware and there's this spec of like, here's how it works. And then you're like actually like, hitting the registers or doing things, you're like, it's not actually doing that. And, you get an appreciation for like all the detail that goes into drivers of actually making these things robust and work, because the hardware never performs to spec. And so anyway, it was this really, excellent foundation that I just wouldn't have gotten otherwise. And really haven't had a chance to kind of go that deep since, but I think it's served me really well.
Yeah, it's kind of interesting as we get into this cloud, as we are in this cloud era of, I haven't touched a disk in quite a while, but back, so I worked at a storage company too. So that was how I knew about Isilon. All the tests you're talking about, I know exactly what you're talking about. where maybe people don't know is as when you're on a physical disk a hard disk where the head actually moves, there is a difference between the inner sectors versus the outer sectors in terms of seek time, in terms of all of that changes the disk performance. And so you might get to your point that spec that says it can do 70 megabytes a second. Well, maybe on average, maybe best case, maybe depends on your seek times, depends on all sorts of things. And it sounds like that's what you're writing.
Yep, exactly. And just trying to, yeah, find stuff that you could actually ship and rely on. And it was shocking, the variance. Like, I think we mostly used a specific line of Western Digital, and then there's like other Western Digitals or other, Seagates that were just garbage, and so it was crazy, like the different lines of which ones were awesome, and then just a bunch that were kind of trash.
Yep, I think that was what we used too. I think we used Western Digitals. We had SCSI ones, and I think those were Seagates. And I think for more like they called it nearline storage, it was lots and lots of storage where they weren't as worried about performance. I think those were Western Digitals too. Yeah, brings back the memories. Well, as you rightly pointed out, you went from Isilon into Google, and the stuff that you worked on at Google are the stories of what we did. So tell us the story of MillWheel.
Yeah, so MillWheel was a stream processing framework. So when I joined Google, so they had just opened up a Seattle office, and the way they did it, they really seeded it with a bunch of very senior engineers and kind of said, "Hey, find cool projects and go build cool stuff." It was such a cool environment because it was so open ended. And Google just had this money printing press in search ads, and so they really were just kind of investing in like, get smart people, let's build cool infrastructure. And so one of those projects was the MillWheel project. It was founded by Paul Nordstrom, who was one of the early Amazon infrastructure engineers. So he'd come over, and that project was 6 or 7 months old when I joined. And there was someone who left Isilon before me who actually landed on that team. I really wanted to be on that team, but they didn't have more space. And I had made this questionable decision in my like interview packet of making this a reference of like, I'm also looking forward to at Google having the opportunity to learn more about UI and front end development because that's something that Google does. And so they were like, yes, we will put you on a front end team. So I actually landed at Google on the Google Analytics configuration UI team, and was like, okay, this isn't what I expected. But I was lucky in that they were on MySQL at the time, and they were growing beyond the scale that they could actually manage to keep the MySQL boxes running. Like it was this constant march of migrating to larger and larger machines, trying to keep the configuration database for all of Google Analytics from falling over. And so I ended up getting tasked with moving that database from MySQL onto Megastore, which was this bizarre system built on top of Bigtable. It tried to take Bigtable and put, Bigtable is very, NoSQL-y sort of a thing. It tried to put a little bit more, not quite multi-key transaction sort of semantics, but it basically built a hierarchical model. It allowed you to have transactions within a hierarchy, within a single key, kind of the same thing that you can get the same thing in Spanner. I mean, obviously Spanner has the full-blown multi-key stuff as well, but they basically gave you this sort of like, I don't know, halfway point towards getting multi-key transactions by using hierarchical nested data. And it was weird just because it was a Java client framework built on top of the RPC interface to Bigtable, which was built in C++. So anyway, I migrated us from MySQL onto Megastore. That was kind of my project there. In the meantime, I was doing like 20% projects with MillWheel, trying to like be involved, and managed to, once I finished that project, got onto MillWheel. So that digression aside, from there on, it was basically all stream processing and data processing all the time. And we were just building out, it was a C++ framework. Google had a ton of data processing. Most of it was built on top of MapReduce, which is very batchy, very, run over large batches. If you're doing something continuous, stitch them together, or just decide, like, I don't care, like, I'll have these day boundaries and we'll just deal with the fact that things get sliced in half. And so it I think it's always been sort of fairly obvious. This idea of processing data continuously and having really low latency is super valuable. And so that was just the whole thesis for the effort was like, let's figure out how to do this at scale at Google. Um, and so they were solving all sorts of interesting problems around like, what is the architecture for doing this? What are the kind of the primitives that you need? It was an actor model sort of a system. So you'd write a MillWheel node, and it basically took in some inputs. You had persistent state that you could manipulate, and it would generate some outputs. And then you would have a configuration language that would let you say, well, this node is here, and it has these inputs and these outputs. And you could essentially build up dynamic subscriptions between them. Like you could even at runtime say, I'm publishing to a stream with this name, and the system would just figure out like which node or nodes that should be delivered to, and you could bring up new nodes that would subscribe to that stream, and the system would automatically start routing, to those new nodes as well. It was just this super dynamic, super flexible system. But one of the early things that they ran into was this whole notion of out of order processing, and like Google did a whole bunch of stuff over data that was user events. A user did a thing, and they had multiple log sources, and they'd want to be like, well, a user, we showed this user these search links and ads, and we have this record of which things they clicked on, and we want to reconcile those, and we want to build up like sessions saying like we want to understand like what are users doing, what are they clicking through when they're navigating through pages, what traversal are they taking. And it became clear very quickly that like just processing things in the order that they showed up particularly when they came from these divergent sources, was not working. And so that's how they kind of went down the path of like figuring out how do we deal with out of order processing. That's where watermarks came from, is this notion of like, okay, we know data is going to come out of order. We'll basically do what processing we can, buffer it up, but we'll also have this notion of progress. And when progress reaches a certain point where we say we believe we have all the data up to this point, or we know for sure, whatever the guarantee was you had, then we'll actually produce a result. And so I think they really were solving these fundamental problems that hadn't been solved before. And for us at the time, like we're just doing this at Google. It was just like, let's see if we can do this. Let's make it happen. And it wasn't until the project had been around for, 4 or 5 years that we started seeing little bits and pieces of stream processing showing up outside of Google. So Storm started to become prevalent. I think Spark streaming, the first version of it, started to pop up in places. And so it was then that we were kind of like, okay, well, this is super cool, but like we're actually more advanced than a lot of this stuff. Like we should write a paper or something, because like it just felt like we've been working so hard at this. We'd solved all these problems. Like we should share it with the world. And so that's where the MillWheel paper came from. And that was 2013, I think. So we published a paper on MillWheel, and that for me was the kind of the beginnings of my career at Google, because basically everything else built on kind of the foundations of what I started working on in MillWheel.
And you touched on it, but that kind of gives us the impetus for creating Cloud Dataflow, Beam, which were the other projects that you did. And as you were talking about the importance of watermarking of out of order data, we've talked about that before. This is the impetus of Beam, where I still think Beam's API is still the best API I've ever seen for handling out of order data. Although you kind of make it seem like it definitely was a difficult problem, but it made it an actual approachable problem that I've never seen an API do before.
Yeah, I was really happy with how it played out. I think it's funny because so Beam, I'm trying to think of how to best frame this story. There were a lot of things that went into it. So the beginning was, I was on the MillWheel team. A bunch of us were. It was just this random independent project in Seattle. And at some point, the powers that be, as they do, said, "Oh, it'd be good for us to consolidate our data processing systems under one manager." And so that was how we ended up getting moved under Greg Tchaikovsky, who owned MapReduce. He owned like Pragal at the time, and also other things that weren't necessarily data processing, like Census and stuff like that. So we got moved under him, and so it was like us. The important projects in this story are us, MapReduce, and Flume. So Flume was this other Google project started by Craig Chambers, who was a UW professor that they poached into Google Seattle. What it did was it built, the goal there was to say MapReduce has this very, very rigid and very basic programming API of a map stage with an implicit shuffle and a reduce. And you can build up these chains of MapReduces to do really complex stuff, but it's like a lot of work. And it's like assembly level programming for distributed data processing. So what the Flume project was focused on was, let's build a higher level language for describing pipelines, and then compile those down into MapReduces into the covers. And then we can do also additional optimizations, like they called it like filter. They call it lifting and filter lifting and like combiner lifting. In databases, they call it push down because they draw their diagrams differently. Like Craig was from a compiler's background, so theirs were kind of top down. Databases are always bottom up, so you get this like divergence in terminology. But basically, they could do optimizations that engineers were doing by hand across multiple MapReduces. They could just do it automatically. Again, a lot like what you get with the database compiler of like, I write a SQL query and it does all this crazy stuff under the covers to make it performant. So Flume had been founded. They're basically a high-level API on top of MapReduce. That was essentially the API that then formed the foundations of Apache Beam, but it was batch-focused. And so by kind of bringing these three teams together, then the other bit of history that's interesting or useful here of how Cloud Dataflow and Apache Beam happened was how GCP came to be. So when Google Seattle was founded, it was founded by this guy, Brian Bershad. Again, he was another UW professor, but he also had a startup in kind of the cloud infrastructure space. Like, this is early days. And so he had this vision that, hey, we should turn Google's cloud infrastructure, the amazing internal technical infrastructure they have, into a cloud product. And so a bunch of the early Google Seattle teams were actually focused on exposing Google infrastructure to cloud. But there was just like zero interest in it from kind of the higher level execs. Like, it was just no one, like, it's not, it's a bad business. It's a race to the bottom. We're not going there. We're sticking with ads and higher value things. They kept building pieces, but finally at some point, like, it was like 2014, 2015, I can't remember exactly. It must have been 2014. Oars decided, crap, we made a mistake. We should have been investing this. And so he wrote this big manifesto that became referred to as the Oars-quake, that was basically a document saying, oops, well, we're going to do cloud. So we're taking TI, which was this large org that he owned, was focused on building infrastructure for Google. We're going to take 80% of that, and they're going to go build what's to become GCP. 20% of you hang around and keep the lights on, keep doing what the other, you plus the other 80% were doing in the past. It'll be fine. We'll build GCP in a year or two, and we'll move everyone onto it, and then we'll all be back working just on top of GCP. That was the Oars-quake. Of course, here we are. I've been gone from Google for like 6 years now. As far as I know, they are still, there's still Google 3, the internal system, and then there's GCP, and of course some stuff's moved over, but like, it's a separate world, and there's a whole bunch of other stuff that, there's a whole bunch of interesting fallout from that. But when GCP was created, there was a very focused desire to start putting out some of the cooler technologies that we had. And that's where Cloud Dataflow came out of that. There's this desire to say, okay, we've got MapReduce, awesome execution engine. We've got Flume, which is this great kind of high-level API for designing data pipelines. And then we've got MillWheel, which has this streaming functionality, which is really cutting edge and cool, and feels like another piece that we should have. We should put all these together and create a thing that ended up being called Cloud Dataflow. The interesting part of this story, as someone who ended up being one of the more visible faces for Dataflow and Beam, is that I was in the 20%. I was actually one of the people who stayed behind. I was the owner of MillWheel when Dataflow happened. But I was also involved in Flume. I was also managing a bunch of that team. I was involved enough in the Dataflow space and streaming in general that specifically I had been working on the streaming extensions in Flume with couple other folks, primarily Robert Bradshaw and Daniel Mills, we've been building out what we've been calling streaming Flume. So pulling those streaming ideas into the Flume API. And so I leveraged that to basically say, look, we're trying to bring this, we want to bring these ideas, this kind of unified batch streaming thing, along with the rest of all the other stuff we built in Cloud Dataflow. But I'm really worried that people aren't going to know what to do with it. Like, they're not going to understand it. They're not going to, realize the subtleties. Like, it is complex. Like, I appreciate you saying that it's a really good API for it. Even as much as it maybe is, it's still, you still got to understand what you're doing in order to use it effectively. And so I was super concerned that we'd invest all this time in building this cool thing and no one would know what to do. So I was like, I want to make sure we get this right, and I want to make sure that people know how to do it. And so that's kind of how I went down this path of like starting to give talks and starting to write things about it to try to educate, hopefully our future would-be customers, like, what is streaming and why, what is the right way to do it? And sort of implicitly then, why would why is the way we do it in Dataflow the right way to do it? And then Apache Beam was spun out of Dataflow because Dataflow initially was just a cloud service from Google and had an open source SDK, but that's open source with air quotes in that Google lobbed some code into a GitHub repository and said, here you go. And we were not seeing the uptake that we wanted because people were like, well, yeah, like looks like a cool system, but like, what happens if you go away, or what happens? And so the decision was made that we needed to have a stronger presence in the open source world. And so the idea was, okay, let's find some partners. Let's take that Dataflow SDK to the Apache ecosystem. Let's make it truly open, and let's try to turn it into a generic high-level programming language, essentially, SDK for multiple engines. Let's make it kind of like a sequel for programmatic data processing, if you will. And so that's, we sort of partnered with the folks in Flink. There were some companies like Talend who were interested. They were JB and crew were kind of some of our early collaborators there as well. And so that's how Apache Beam came about, and how Google kind of started down this Apache path with Beam, and that's where Jesse and I then ended up meeting up, because Jesse got involved early on, and so that's kind of the meandering path of how we ended up in that space and how I ended up participating, even though technically my day job was MillWheel.
Yeah, Google's kind of funny watching it from the outside, where as you tell these inside stories, I guess meandering isn't the right word, but serendipitous isn't the right word either. Let's see, I'm trying to think the right word here. Unmanaged. They didn't unplanned. That's the right word. From the outside, it always looks unplanned. And in fact, looking at it now with Gemini, for example, or it was Bard before that, and everything. It's just Google has this unplanned thing that it's kind of like this, and then it kind of comes together eventually. Where when people from the outside, you didn't say it specifically, but at that time when you were doing the MillWheel, every question, every time I said, hey, let's use GCP for something, they'll say, we shouldn't use GCP. Google's just going to stop it eventually, and we'll be stuck holding the bag. We don't have those conversations anymore, but it's always that from the outside, oh, hey, Google threw something over the wall. Are they going to stop it? Are they going to kill it?
Yeah, they were notorious for that. And that was a big challenge with GCP in the early days. So they're just kind of like, yeah, when it doesn't plan out, what's going to happen? You're going to be like, all right, you got 15 days, and then we're pulling the plug because, it's going the way of Reader, So.
Google Reader. Nothing's replaced it, unfortunately. So why did you end up leaving Google? I don't think I ever had that conversation with you.
So I left Google. I mean, so the impetus for it was that, so Greg Tchaikovsky, who I had mentioned previously, he was my manager briefly when MillWheel moved under the umbrella of MapReduce and Flume and that kind of broader set of teams. And then he was a director at the time. So I very quickly got moved under some other manager under him. But I reported up through him for the rest of my time there. So for a solid decade, Greg was kind of the person I reported to. And then in mid 2019, out of the blue, he was like, "Hey, folks, I'm leaving. I'm going to this little company called Snowflake," which I think folks on the BigQuery side were far more aware of it because they were already kind of competing. But like those of us who weren't really in the BigQuery space were kind of like, Snowflake? Like, who the heck is Snowflake? And why are you like, you're a VP of data analytics at Google and you're going to run engineering at this like podunk little startup? Like, that's weird, but okay, have fun. And he was quickly ushered out the door because there was such a such a competition between the two. But he came, he kind of came knocking at some point down the road and was like, "Hey, would you want to come work at Snowflake?" And I was like, "Okay, well, I really like Greg. He says it's really a good place, a great place to work, very friendly, friendly co-founders, and they have a big vision for where they want to go. The company's doing really well. It's pre-IPO, like it's a good chance to get in." And I looked at it and I'm like, "Okay, well, where's the office?" And I saw it was in Bellevue. And I was like, that's a hard no. Because I live in Seattle. For those of you who don't know the Seattle area, like there's, particularly from like a tech perspective, there's basically, well, in general, but there's kind of west side and east side. Like there's Seattle proper and kind of the various cities around there. That's the west side. And then the east side is Bellevue, Kirkland, Sammamish, and then even further out is Redmond. And there's this big lake between it with two floating bridges. And so the commute is not, even though it's not that far, it's like 11 miles or something. It's, particularly at the time before COVID and before, people being, working from home a lot, it was like a 55 hour long commute for me to go to Bellevue. And I had specifically like moved to Fremont in Seattle, the Fremont neighborhood, like a mile from Google Seattle, so I could walk. Things had shifted, and Google had moved all the cloud folks that we were under the umbrella we were under down to South Lake Union. Fine, it was like a 20-minute bike ride. That's still a pretty good commute. Like I'm getting actually a good workout, and it's not too long. And so for me, it was just like I don't want to be stuck in a car. Like I don't want to be, But he's like, "No, but like it's a really good opportunity. You should look into it." So I'm like, "Fine. Like I trust you." So I met with the founders. I really liked them. I loved their vision. It felt like we were all kind of headed in the same direction, wanting to do things. Like for me, I was at this turning point in my career where like we've done the MillWheel stuff, we've done Beam and Dataflow. Those were all kind of moving forward. The roadmaps were established, like they were going somewhere. But for me, I had felt like there were all these open problems in stream processing that we really needed to solve. And I'd actually given a keynote at the Devs conference in 2019 where I basically laid this out. And I didn't do it from the point of view, or I didn't go into it thinking, well, what do I want to do next? It was mostly just me being like, well, what the heck am I going to talk about? Well, there is a bunch of stuff we should solve for stream processing. So I just kind of laid out like, here's all the problems that I feel like we still need to solve. That ended up becoming basically this manifesto for what did I want to do next. It was really like, I'd love to go and try to build the next generation of streaming system that kind of solve these problems. And like the big ones were ease of use, for one. Like streaming systems by then, this is 2019, were really capable in what they could do. And their APIs had gotten better, with Beam and others who had built on top of that. They'd gotten better at being easier to use. But I don't think anybody would describe it as easy to use. It was still required teams of software engineers to build and maintain this stuff in order to do something that like any random person could describe. Like I have events coming in from views and clicks, and I just want to join them and see which views led to which clicks. Like anybody can tell you, like, I want to do that and I want to have it happen as fast as possible. That's stream processing. But to actually do that would require like 6 engineers and 6 months of work, and then 2 engineers full time to keep the darn thing running. So for me, the next frontier was, how do we make stream processing so easy to use that someone that can describe that problem to you clearly, like, which is literally anybody who understands kind of the business problem at hand, that they could actually just deploy this streaming system and have it happen. So I wanted to go build that, and I knew I could probably do it at Google. but it was going to be like, what my job was going to be there was going to be trying to convince, directors and VPs across like Dataflow and BigQuery and Spanner, or some set of these different projects. Hey, let's collaborate and try to make this happen. And I just knew I was going to be in meeting hell forever, and it was going to be really hard, and it just sounded exhausting. Whereas at Snowflake, they had these two passionate founders who had a vision that seemed aligned with what I wanted to do, and it just felt like, okay, I could go there and maybe I can make it happen. And there was a lot of alignment on kind of the product values too. Like they built this very simple, easy to use system that did very complex things under the covers. Like it felt like the right place to do it. And so it just I took the risk and decided to give it a try. And we will, I'm sure, talk about sort of how successful I was at actually delivering the vision that I had, but it absolutely was worth it. Like, I learned a ton. It was a great set of people to work with, and it really did allow us to, I think we still were able to push forward the state of the art, even though maybe we didn't push it forward as much as I had envisioned, but it ended up being a really great opportunity for me.
Well, yeah, do tell. So on one of your notes, I'm actually laughing. You said it's a very Apple approach, very Apple ecosystem approach to data. I think that's a good way of saying it. That walled garden of Snowflake, where you can either have this open chaos of the Bazaar in the open source side, or you can have this curated thing. And I never can quite. It's so hard to decide one or the other, where I'm much more of an open source sort of person saying, I want to do what I want to do, and I'll stub my toe and I'll do that. But then on the other side, you have these people saying, oh, look what I can do in Snowflake. Tell me more about that. How are you going to deal with that on the structured streaming side?
Yeah, so for me, like I think historically I've been kind of similar to you. I've been more on the open source or the the sort of broad connectivity sort of side of the world. And I think we'll probably get to this later. I'm sort of back there with Redpanda, but when I went to Snowflake, my reading was this: I wanted to be able to build the best streaming system possible, and I wanted it to be useful and used by people who actually cared and actually did it to accomplish meaningful things. Doing it within a walled garden, curated ecosystem only works if you have enough business inertia behind it. And that was the thing that Snowflake did have. It was very clear that like there were tons of people who were willing to just throw money at Snowflake and be like, give me more, give me more, give me more. They were doing amazing stuff with it. So it very much like the Apple ecosystem, it felt like, okay, they've got enough inertia, they've got the customers, they've got the data. This is actually, if you're going to pick a walled garden to build in, this is the right walled garden, because there's just enough there that you can do something that's not going to reach everybody, because not everybody's going to be in the walled garden, but enough people are there and enough data is there and there's enough value coming out of it that you will make a material impact. So that was really my thinking around that.
And the product that you eventually came out with dynamic tables. Tell me how that came about and how that worked.
Yeah, so when I got there, I tried to lay out kind of a vision of all the things that we should do in the streaming realm. So it was like you have to start with ingestion. Like you need to be able to stream data in. So that was kind of where we actually started, was on the ingestion side. I had pitched we should have a Kafka API, much like the thing that Databricks launched recently. Like it looks like a Kafka endpoint, but it's just going into your data warehouse. I had pitched building that. Of course, wanting to build it up to multiple gigabytes a second scale and things like that. We ended up building a thing called Snowpipe Streaming, which did work really well at scale for certain use cases, but had other shortcomings. And we didn't need to go into that necessarily, but started out on that. And then once we kind of got some traction on the ingestion side, then we were able to move into processing. And really, like when I had joined Snowflake, one of the things I said was, well, obviously we're going to do materialized views. Like that's just that felt like the right path. Like for me, it was the example I described earlier, where it said somebody can show up and say, well, I got impressions and I've got clicks, and I just want to see like which views or impressions led to which clicks. Like, I just want to understand that. Like, that's a business problem you can describe. A materialized view, anyone who can write SQL, which is quite a lot of people, could describe something like that reasonably. And if they can just describe what they want that data to look like, and then you can materialize it under the covers for them continuously and with low latency, to me, that felt like the path towards solving ease of use for stream processing. So that was really the impetus.
It was the holy grail. It still is,
yeah,
I think.
Exactly. And so that was why that came about. And I would say I was successful in helping advocate for us to build it the way we did through, both persistence, but also it aligned very well with kind of the database-centric view of the world that Snowflake had. Like, that was, I think, the biggest challenge of trying to do the new things at Snowflake during that time that I was there, was that you had the company had been so successful. They had this inertia around, like, look, we built this data warehouse and everyone freaking loves it. It's just amazing. So obviously our vision is good. We need to stay true to that. And so, at the time, because they were making tons of money, they brought in a bunch of really smart people saying, let's expand outward. But there was this constant tension between, like, how do we stay true to what we kind of feel is this classic database centered vision around things, and how do we branch out into new things? And so within that tension, it was hard to get certain projects moving forward. They really struggled a lot on the ML side and the AI side as well for years, kind of trying to figure out, how do we do this and how do we fit it in? But dynamic tables kind of fell into that niche of, like, we're pushing forward the state of the art, but, like, materialized views are a thing. Like, it makes sense from a database perspective. There wasn't any aversion to, like, this idea of, like, let's build in a materialized view beyond just figuring out how do we fit it in cleanly, how do we make it work well, what do we call it? We spent an inordinate amount of time on naming, of course, and I wanted to call them materialized views, but they already had a materialized view object, which was very different. It was very focused on, like, specific subset of operations and kind of query optimization under that, like automatically swapping in a materialized view when you query data sources that are based off of that materialized view, even if you don't know that it exists. So we couldn't use materialized view. I think we landed on materialized table at some point because they really wanted to give this feeling that, like, this isn't a view and that it's going to go compute a bunch of stuff. It's actually pre-computed. It's more like a table. So it was materialized table up until, like, a month before we launched. And then James Malone from our Beam days, through some various reorg, ended up owning dynamic tables all of a sudden when he hadn't been the product manager before. And he shows up and he's like, man, materialized tables is a crappy name. Like, why don't we just do dynamic tables? Like, that's better. Like, that gives some sense. And we all kind of looked at each other and we're like, that's a pretty good name, actually. How did we not, like, we looked at so many names, but somehow that hadn't popped up. And so, like, in the very last minute, we swapped over to that. But yeah, really the vision was, build proper streaming materialized views and just make it work. And I think the key, the key thing that made it possible was, building on top of Snowflake's really sophisticated and frankly really well written C++ execution engine as, the query engine. We built on top of that. It's really a very micro batch sort of architecture. Micro batch has a lot of shade thrown at it throughout the streaming community. It's a good way to go. Like, it works really well in a lot of circumstances. And I think the other piece that we haven't touched on yet, but was also another key part of what I wanted to do in this next gen streaming realm, was this recognition that I got from 10 years of working on streaming at Google, that, like, everyone, you go and ask someone, you say, hey, how quickly do you need your data? They're all going to be like, as fast as possible. I want it in seconds. And you say you can build an amazing system that will do that. And you'd be like, okay, we can do that. Here's how much it's going to cost. And then they look at the freaking bill and they're like, oh, you know what? 6 hours is actually fine. Let's do 6 hours. Can you do it cheaper in 6 hours? And like MillWheel, the system we built at Google, it couldn't do 6 hours. Like, it couldn't give you economies of, sort of, not economies of scale, I guess economies of latency. It couldn't scale back and say, okay, well, I'll just give you answers every 6 hours, but it'll be like 200 times cheaper. And so the other part of this next gen streaming ease of use thing that I saw as really important was spanning this latency spectrum and being able to say, here's a streaming system. You can, in plain language or SQL, whatever, simple terms that, like, a broad set of people can interface with, describe what you want to have happen, and you can do so across a broad latency spectrum so that you can optimize these sort of dimensions of cost and latency to actually meet business needs. Because in reality, the vast majority of business problems don't need sub-second or even single-digit second latency. A minute, 10 minutes, an hour is totally fine. And if it's literally 100 times cheaper to do that, it's actually worth it. And so you've got to really kind of balance out, like, where is the latency worth it? Where is it not? And so that's why this micro batch architecture actually made a ton of sense, because 60 to 80% of the use cases fall very nicely into a not super optimized sort of micro batch architecture. And so what we built was the system that essentially runs micro batches over the data. You would write a SQL query saying, this is what I want the results to look like. We would analyze that query, and using this very cool change derivation system that the other folks on the team, I drove the project, sure, I helped make it happen, but like the actual guts of it were, built by a bunch of other smart people, besides myself, Dan Sotolongo, Daniel Mills, again, who was on the streaming Flume stuff, Leon Papke, a bunch of folks on that team came up with this very clever, well-designed change derivation system that would, in the analyzer itself, you'd get a SQL query saying the results should look like this. It would look at the kind of the initial plan of like, well, here's the joins that are happening, here's the things that are happening. You'd label which inputs would be you'd want to consume as essentially deltas, as sort of the changes rather than the full data set. And from there, propagate that all down, and you'd have rules that were built out to be like, okay, well, if you've got a join and you've got deltas coming into it, that join needs to transform into, I forget that, we have a paper on it. You can kind of look at the details, but it's something like it's like the delta of side A joined with the current version of B, and you union that with the current side of A with the delta of B or something like that. It allows you to compute incrementally, what is the change in the join. So they could take a regular query plan and transform it into an incremental one that you could then execute using the same engine, because it's still the same primitives under the cover. You've just kind of shifted the kinds of operations you're doing, and by doing that, actually run incrementally the processing. And so you wouldn't have to look at the whole data set necessarily, or it wouldn't have to always be sort of based off of the amount of work done would not necessarily be commensurate with the amount of the size of the table itself. It could be sort of relative to the size of the changes of the input. But there's a limited set of operations that you can do incrementally. And of course, as we build it out, there's a limited set that we've actually implemented. And so the fallback was, if we couldn't auto incrementalize it, we just rerun the whole query again and rematerialize it, which again is what people are doing anyway most of the time. That's what DBT built their entire business on, of like, here, write a SQL query, and we'll just kind of run that query for you on Snowflake or whatever system in the background for you as you go. And so by doing that, it allowed us to deliver to customers this automatic incrementalization, which is really kind of the like you said, the holy grail for stream processing. Is you don't even know that it's happening under the covers. You just say, make it look like this, and the system figures out how to do it incrementally. But we weren't limited by the incremental space. You could do it for you could say anything, and if it had to be full refresh, you just run it full refresh, and the system was very well optimized for batch queries and things like that. So like it did a good job at that too. And so just the ease of use factor was really nailed the ease of use factor that we needed, but also allowed us to gradually over time expand the amount of stuff that we could do incrementally. And we did see customers loved the incremental versions of things, because it was just the costs for doing the maintenance would just drop dramatically.
All very true. That is interesting. So let's talk about Redpanda. And to do that, we will switch over to our whiteboard. So let's talk about Redpanda. To start off with, what is Redpanda data?
So Redpanda data is, I think there's sort of two answers to that question. There's the classical answer that largely predates me at the company. I joined 6 months ago. So sort of everything up through Series D funding, and then there's Series D and beyond. So prior to my joining, prior to Series D, which happened a month before I joined, Redpanda was a streaming company, and specifically they were in the streaming messaging business. So they built a high performance C++ based. The short version is a Kafka implementation. It's a distributed log built using the C star framework, this sort of thread per core high performance framework. Has a custom raft implementation that handles all of kind of the data replication and consistency stuff. So they built that. That was built by our CEO and founder Alex. Came out of kind of, he'd been at Akamai, so he had been building a stream processor way back when I was working on MillWheel. That's when we had first met. We met back then. The company was called Concord. Concord ended up getting acquired by Akamai, and so he was there doing some stuff, and he kept finding like he was having a really hard time pushing the volumes of data he needed to into something like Kafka. And so he kind of just for fun went down this path of like seeing, okay, how much data can I really push through hardware? Like if I really get down into sort of understand the deep hardware primitives, how much can I actually push through this thing? Because you look at like you talked about earlier, you look at the specs, it's like I should be able to do, I should be able to push X amount through a given machine. And that's not what he was seeing, remotely pushing into something like Kafka. And so just as a thought experiment, he kind of built this thing out and found that by really approaching it from kind of a first principles perspective, was able to do amazing, just incredible amounts of throughput on this thing. And so then he went and put a Kafka API on top of it, like a Kafka API parser as a front end. And suddenly you had this thing that you could drop in with, anything that spoke Kafka, or at least the subset of Kafka that they supported, you could just drop it in, and you went from, I need 50 nodes of Apache Kafka, running this Java thing with Zookeeper and all that, to 3 nodes of Redpanda, and it's like not even fully utilized, and it's a single binary, and it's super low ops, and so that was the birth of Redpanda as a company. And actually, the company was called Vectorized initially. Redpanda was just that product, the Kafka broker product. But it was so successful, and everyone loved the name, and the mascot was so adorable that they eventually just adopted it as the company name as well. And so that's where Redpanda started. And they, over time, then expanded into kind of additional products in the portfolio, all centered around stream processing, stream messaging. So they acquired a UI, which is Redpanda Console, which works interoperably with any Kafka system. You'll see a theme here. We've actually, in the last 6 months, we've kind of formalized what our 4 product values are that we kind of center around of simplicity, efficiency, interoperability, and safety. All of those were present in the very first at Redpanda, and you kind of see this with like Console was a UI that they acquired, a little company that was building it. It's a fantastic UI for understanding your Kafka clusters. Works with any Kafka system. So we've got tons of Apache Kafka users or MSK or Confluent, users that use Redpanda Console to understand what their system is doing, even though they're not even using Redpanda for anything else. A little later down the line, also added Connect, Redpanda Connect. It was previously an open source project called Benthos. But as a messaging system, one of the key things your customers need is to be able to connect data from different data sources and get it in. Kafka Connect, for anyone who's ever used it, has its challenges. We'll just leave it at that. And so they found a need to have something that was a little more high performance and kind of fit more within the mindset of how they built systems. And Benthos was built in Golang, so again, native code, really optimized for performance, and ended up being a really good fit. So that became kind of the broader product portfolio. I think the other interesting thing about Redpanda from the product perspective is they have a broad focus on kind of meeting customers where they are as far as deployment mechanisms go. So they started out as like a self-hosted kind of a thing. Basically, you license the software, you go run it, and we just make it super easy to run, so it's not that much work. Moved into having a cloud SaaS service as well. There are times where that makes a lot of sense. So more aligned with kind of how MSK runs things or things like that. But then also, I think the big one was they also really pioneered this notion of BYOC deployments within the, kind of this streaming space, of which BYOC stands for Bring Your Own Cloud. And the idea is you've got your own private VPC, you've got data in there that you want to be, running through Redpanda or whatever, but you don't actually ever want it to leave your private cloud. Like, you don't want to send it into Redpanda running in a SaaS serverless environment. You want Redpanda in your VPC, but you also don't want to punch a bunch of holes through from the outside to let people reach in and kind of manage these clusters or things. So what BYOC lets you do is you deliver a single agent, as it's called, which going forward is a bad name, but Redpanda agent, which basically is kind of like the control plane. And what it does is it effectively, they set up some permissions, so you've got access to kind of manage some Kubernetes resources that the customer sort of locks down and says this is the budget and these are the ACLs, and then the agent phones home. So you never need to punch a hole through. It phones home. It can also absorb a bunch of the network rules and things. Like, there's a whole bunch of sophistication there, but basically allows then the agent then allows us to orchestrate and manage Redpanda clusters on behalf of the customer in their private network, without us ever being able to see the data or touch the data, and without them ever having to poke holes through. So having these three modalities of kind of on-premise, self-hosted, self-managed, BYOC, and serverless is kind of the other part that makes Redpanda unique. And BYOC in particular has just taken off like crazy. Like, it really meets a need that customers have as far as wanting to maintain sovereignty over their data, but also not wanting to have to manage all their infrastructure all the time. So that's sort of the part one of what was Redpanda up to Series D. And then I'd said there's a part two, which is kind of Series D and beyond. What is it going forward? And I think with the Series D, there was a statement made that that specific investment round was focused on helping the company expand into AI, specifically agentic AI. And so where we're headed going forward as a company is building out what we're calling the agentic data plane, effectively trying to solve the problems that exist for why can't you deliver, why don't we see AI agents all over the place in the enterprise today? Because it's trivial to build an agent currently. Like, with Claude Code, you can spend an afternoon, build a useful, very practical agent. Why don't we see this stuff everywhere already? Like, and I think as we've talked with customers and looked at the problem, there's this big challenge of how you deploy those agents safely and feel like they're going to do the things you want them to do. They're going to access the data you want them to. They're not going to go do things that you don't want them to. All that sort of stuff. There's a big governance portion of it. There's a fair question of, okay, you want to solve that problem. Why are you, as a streaming company, the right company to do that? And I can go into that if we'd like, but I just want to kind of wrap up, like, that's kind of where we're headed as a company now. So going from being a streaming company, expanding, using that as a foundation, but really headed into this agentic space. And our goal and vision is to be the company that really enables agentic AI to see broad proliferation across the modern enterprise.
Okay. And so we've got that agent, and I understand that we'll call it. What was funny is that was the name. Something running on a computer doing this as an agent, and now we have the AI agent. So I guess we have to call that AI agent. So we have this agent process, and we have this AI agent, and by having the granular ACLs, by having this granularity, we're able to punch through in a way that we couldn't before. Is that the general gist of that?
Well, so what you're alluding to is the general gist of BYOC. I would say I wouldn't conflate BYOC with AI agents. Like, I'd leave those somewhat separate. Basically, BYOC, the Redpanda agent, as it was unfortunately called, enables you to. What it enables is the delivery of a managed service in the customer's private network without ever having to punch holes in, and without us having to have direct access to any of the data or anything in there. It's a very sort of locked down, phone home way of running a managed service in a customer's VPC. That's BYOC. And then all the AI agent stuff is largely separate. BYOC is a critical deployment mechanism for AI agents, which I can go into as well. But it's the AI agents are very separate from that somewhat unfortunately named Redpanda agent.
So that leads us into this question of what is this exact challenge that we have for agentic AI?
Right. So I've got like a 20, 30-minute talk that I usually give on this. I'll try to distill it down, but I think that the core piece of it is really it all centers on the unpredictability of agents. Like when I give the talk, this is kind of silly, but I'll draw it out here on the whiteboard. Do you play Dungeons and Dragons?
Yeah, I've played it before.
So Dungeons and Dragons is, within Dungeons and Dragons, there's this idea of alignment and alignment charts, and there's these memes across the internet of kind of where they'll build up these alignment charts and then they'll throw like TV characters or whatever in there. And the idea with the alignment is it gives you a sense for kind of a character's motives or things that they do. And so the way that they work is, oh my gosh, I cannot.
There's the lawful, there's the chaotic, and
there's chaotic over here. And then so from left to right, left side is lawful, right side is chaotic. Lawful is law abiding, chaotic is, I do what I want, right? And then from top to bottom, it's good on the top, evil at the bottom. Good is selfless, altruistic. Evil is selfish, malevolent, that kind of stuff. And then the middle ones are neutrals, right? So like the middle square is neutral, and so like the one I usually use in my talk is like the Muppets, right? So it's got like Kermit's up on lawful good, and it's got like Animal is chaotic neutral, for example, and like Gonzo is chaotic good. So like this kind of gives you a sense for like how these people function. The reason for bringing this up, besides the fact that it's fascinating to ask audiences like, who plays Dungeons and Dragons? Like the very first time I used this was at our sales kickoff. Bunch of non-engineers in the room. So I was like, there's not going to be that many Dungeons and Dragons players. It was like 10%. Next time I used it, I went to a tech conference, about the same number of people in the room. Everybody there is like software engineering. It was like crickets. I think there was one guy. I was just like, you gotta be kidding me. Like I always thought it was like a tech nerd thing, but anyway, so I was glad that I hit pay dirt here with you of having someone who actually played Dungeons and Dragons. Anyway,
the big question is, where does Tyler Akidau fit in this? Are we here? I'm thinking right here. A lot of chaotic evil there.
Sick burn. I think I'm probably, if I had to pick, I'm probably somewhere in true neutral or true good is my guess, if I'm being honest. Maybe towards the chaotic side. I don't think I'm that chaotic though. Like I appreciate chaos, but I also reckon, I'm pragmatic is what I am, and I think that's kind of what the neutral ends up representing on all of those. So I'd probably land in true neutral. But the point of having this, exactly. Thank you. The point of having this chart is to say, if you think about AI agents going forward, they're basically digital employees that we're wanting to bring into our enterprises. You think about what we do when we hire human employees, we put a lot of energy into kind of vetting them and making sure that we hire the right employees. And it's this long process of like, you've gone through school, you've had some jobs maybe, you've built up this resume showing what you can do. You go through this interview process where you speak with other humans for, spend a bunch of time kind of both assessing domain knowledge, but also reasoning about, what is your culture fit? How, are you trustworthy? Things like that. There's other aspects like you're a functioning human in modern civilized society and you're not in jail. So that tells something about your willingness to follow rules and things like that. And so like the whole point is that like the goal here at the end of the day is to hire human employees that ideally are lawful good, but practically I think they kind of end up being in this upper left quadrant of like that's kind of where humans end up. It's like lawful good to true neutral, and like a place like Google, for example, we had a bunch of chaotic good people there, and they thrived. It's fine, but I think most businesses that aren't so tech heavy are probably a little more focused up here. The challenge with AI agents is that despite all of the energy that goes into trying to push these LLM models up towards the lawful good side, they are squarely hanging out in the chaotic realm. If you're lucky, it's chaotic good. That's pretty much the best you can hope.
That's what I was just thinking. We need this just crazy, not chaotic.
Batshit crazy.
That is the exact word I was thinking of.
Yeah, so maybe we need an extension to the grid, and like agents fall somewhere in that. Like today, I always feel like I need to preface this because someday the robots are going to take over. I don't want them to come back and be too mad at me for this. But so that's the core challenge. But when you look at it more concretely, like what do you need in order to make enterprise agentic AI work? There's a whole bunch of pieces to it. There's context building and maintenance, right? Like agents need to query data sources. They need to have context to make decisions. They need to be able to run those queries against that context. So they need to do data querying. You need authorization and identity, right? You need to know which agent is this, what is it supposed to be able to do, what are its permissions, so that you can then enforce governance. You need governance saying, well, this agent's allowed to read this data set but not write it, or it can read only this table within this database, and it's only allowed to send an email to this person or this agent to ask for help, or maybe it's given the red button. It can actually push the red button itself, but it's those sorts of things that are kind of captured in access permissions. You need to be able to audit the things they do. Like, unlike most of the software we've historically built, where you could be like, oh, well, this did a stupid thing. Where was the if statement, or where was the weird race condition or bug that made that happen? You can't do that in an LLM. All you can do is say, well, I know all the stuff that went into it. I know all the things it asked. I know all the things it got back. And I know what came out the other side. From there, I can kind of infer this was what led us to have that happen. So you really need to audit everything that goes into and out of these agents in order to reason post facto about their behaviors. And I think it's worth calling out that from an auditing perspective, we've been doing auditing for a long time in our enterprise systems. But for humans, historically, it's primarily been focused on kind of access points, like Tyler accessed this database, Tyler accessed this database table. They don't record literally everything that I pull out of it. Maybe they record the queries that I run, but they don't record the data itself. But if you want to reason about what an agent did, you actually need the data. You need to be recording all of that stuff, and it's a lot of data. Very related to that is the topic of evaluations or replay and validation. As you're designing and building agents, and as they live over their lifetime, you need to be effectively evaluating, are they doing what they need to be? Are they doing a good job? To put this in sort of human employee terms, it's basically performance reviews, like ongoing performance evaluations of, is this agent meeting our needs? Because it's anybody who's actually built a real agent and deployed it knows that there are instances where you built this agent, like, this thing just works. This is amazing. I love it. Like, it's doing exactly what I want. And then 2 weeks later, suddenly it just starts doing crazy stuff. And you're like, where did that come from? Like, that is not what you were doing before. And so you need to be constantly evaluating things. Ties in very heavily to that auditing side. In order to do the evaluations, you need to be knowing, like, what use case happened here? What was the outcomes? Were these good outcomes? Lots of observability happening. And then there's a whole bunch of problems around routing data, moving data around. Kind of two big examples that are somewhat different. One is, think of like fraud detection. And we could actually draw this out.
Let's draw this. Go to Whiteboard 2.
Oops.
Little arrows on the top.
So imagine you've got, let's see, how do I usually draw this out? So imagine you've got a data set here. I'm going to draw it as a circle. And you just want to perform some kind of fraud detection on it. Historically, we've invested a lot in the last, more than a decade on, piping that into ML models that we've trained and created in order to give us, some reasonably good estimate of, like, I can look at a thing coming into this and say, I believe this is fraud or not. And then out of that, you will then send to, say two different, you've got, like, because it's easier, right? I'm going to say yes and no. The yes side is, yes, this is good. It can go to the, think of it as a spam detection bot. Like, here's an email that's coming in that's going to land in your inbox. Should we let this through or not? Yes, It's good, we let it through. No, we don't, it goes to spam. The way they have to tune these systems is like there's always going to end up being some amount of false positives and false negatives, right? You ideally want to get those numbers really low, but they aren't perfect. For those borderline cases where like you've got this really well trained model, but it gets it wrong, oftentimes those are things that agents, particularly when they can go and gather a little bit of additional context about either the sender in question or the content of the message or the person it's being sent to, they can make a better determination. But you can't just say, well, I've got a fraud detection AI agent. I'm just going to plumb my 20 gigabytes a second data feed into that AI agent because these things are really expensive, right? Like the GPUs involved, the amount of time it takes for it to kind of think through the process. I mean, they think a lot faster than we do, but they're still thinking. It takes a lot longer than just inference on an ML model. So it's not practical to shove everything through an AI agent, but it is practical to say, okay, we've got our ML model. Maybe we'll even trim it back a bit so that we'll say no, or at least we're not sure about more things than we used to. So we'll kind of decrease the amount of false positives that get through, but we'll have more false negatives. But we'll send all of those negatives, instead of sending it directly to the no pile, we will put an AI agent here, and we'll send this greatly decreased set of no's from the ML model, the ML inference, to the agent. Let it do a deeper investigation, and ultimately come out with a better determination of is this fraud or not, or is this spam or not, and then let it send the rest of those to the yes and no, thereby increasing our ability to give good answers. This is you need these kinds of challenges exist all across kind of AI agent deployments because you're integrating with systems. You can't just, it's not practical to just say, here's a bunch of agents, let them go do everything. They'll take care of it. It's too expensive. They're not really tailored for all of these use cases, but you got to tie this stuff together. Another related kind of thing you want to do with routing. How do I do another board here?
Just press to the right.
Oh, yeah. Another related kind of thing to routing is multi-agent coordination. So another example that we've seen with folks is you build up an agent and there are either challenges with sort of whether the quality coming out of it is good, or with it being subject to sort of these poison pill kinds of prompts, or basically inputs making it do weird things that it shouldn't do, but just every LLM suffers from some number of these. Like you can send it a certain type of a thing and it'll just kind of go crazy or do weird stuff. And so what you end up wanting to do in these cases is say, I'm gonna have an agent that makes a decision. So this number one agent here, it's my proposer. It's the thing that like you say, here, I want you to propose a plan. This is what you say the outcome should be. Then you build up a suite of validator agents who are just there to check that agent's work. And maybe because you want to mitigate the likelihood that somebody's going to get hit with one of these prompts or inputs that makes it make a bad decision or kind of go crazy, you use 3 different LLMs there. Maybe you've got OpenAI as one, Anthropic's another, and you've got Llama as the third one. And only if all 3 of them say thumbs up, yes, this output looks good, do they then send that finally down to this last agent, or maybe it's just a system that applies the change. So you've got all these sorts of scenarios where you need to do orchestration or coordination amongst these. But kind of talk through all these pieces that go into enterprise AI. To kind of reiterate, it's like context building and maintenance, context querying, auth, governance, auditing, evals, validation, and all this routing stuff. The thing that struck me as I kind of started diving into this after I joined Redpanda was how many of these are actually data streaming problems or are well solved by data streaming problems. It's like 3/4 of them are. A bunch of them, like context building and maintenance, it's just a no-brainer. Like that's basically just streaming ATL. We've done that for, no one's going to question, oh, you're wanting to get data in, transform it, and get it in the right shape. That's a streaming problem. Like everyone agrees on that. There's things like auth identity. That's not a streaming problem. Fine. But then there's some interesting ones like governance. Governance, I think, is the really intriguing one. Governance itself doesn't have to be a streaming problem. But in the context of AI agents, it's actually a really good way to solve a problem. So if I draw this out, how am I going to do this? So imagine you've got a bunch of data sources. I'm going to do a terrible job of this, but we're going to draw a bunch of data sources. Just imagine these represent, these are databases, these are SaaS systems. Here, I'll draw some little cloudish sort of things. These can be the SaaS systems. So we've got like data stores, we've got SaaS systems, and then I'm going to do these numbers. This isn't going to be a detailed diagram, but I'll do a couple agents, right? And you imagine you've got like, agent 1 is consuming from like a cloud system and a data store, and agent 2 is consuming from like these other data stores in this cloud system. If you think about the modern enterprise and where we want to go with AI agents, in aggregate, in the long run, you want to have your agents connected to all of the data within your private networks and your private enterprise. Any one agent isn't going to be, but for agents to be digital employees and help in every facet of the business, eventually you're going to want to have connectivity everywhere. And so that means if you want to, ideally, you also want to be able to manage the access to data, the access to systems, kind of the access controls, the things they're allowed to do, and all of the governance and oversight of these things. You want to kind of do it uniformly. You have two ways you can do it. You can go to each of those individual systems and have policies in place for like, well, agent 1 is able to do this sort of stuff. Agent 2 is able to do that. It's totally doable. But in a large enterprise, you're going to have, a small company is going to have dozens of systems. A large enterprise is going to have thousands of these. It's just not practical to try to lock down each one and like make sure that the policies are consistent across these without a bunch of work. Whereas if you think about what agents are doing, they're often pulling data in, streaming data in, using that as context, making decisions, and streaming outputs out. If you use a common streaming interconnect amongst all of those agents and use that, then naturally becomes a uniform place of enforcing governance across all of these. So that's why a streaming company like us, who's really good at connecting data sources, connecting systems, and letting data flow in both directions between them, becomes a natural place for enforcing governance in the agentic world. Kind of service mesh for agents is kind of a pithy way of pitching it in some ways.
Well, that was the question that when I started hearing about streaming companies starting to say, hey, we're going to be in AI, or we're going to start doing AI agents, I thought, okay, great. You and everybody else, you're now trying to figure out how to pivot into AI to work that into your marketing. My question there was, why wouldn't you just have this be an RPC? This seems like this is a great place, but you also get into the issue of now for something like this, if you're doing 2 queries at once, you're now faced with the problem of doing an orchestrator where you now have to wait for this one to finish to this one to finish. How does Redpanda help you with that?
So I think my answer to that is, I'm not here to tell you that everything should be streaming through Redpanda in this diagram. What we're building, what we're calling the agentic data plane, is a multimodal system that incorporates RPCs where it makes sense. It incorporates distributed logs where it makes sense. It incorporates queries where they make sense. Like it's, to try to fit everything into a streaming bucket, I think is oversimplifying the problem. If you show up and basically say like, hey, we've got this awesome streaming system, we can run agents in it and we can pull data in and like, this is going to solve everything you want. It's really not. Like it's not, I don't think that's actually the right approach. There are places where like RPCs actually make sense, but you do need like where Redpanda, what we're calling Redpanda streaming going forward for kind of the, helping focus the discussion, the Kafka broker kind of thing that we built. Where Redpanda streaming really does play in though is because you want to have auditing everywhere. You want to have all of your observability, all of the data that's actually flowing through this. You do want that logged somewhere for the sake of governance and auditing. That needs to be at play as well. But there are going to be places where you actually do want that RPC connection. And so I'm not coming here pitching like there's no RPCs whatsoever. For us, it's an expansion beyond just being streaming. Streaming is a key piece of it. It falls under a bunch of these the aspects that we see as important, as I kind of called out earlier. But we as a company are moving beyond just streaming. We still do streaming, but we've added a SQL query engine. We're adding AI gateways and a bunch of RPC-based stuff tied into it. I think the real value comes from tying this stuff all together and enabling you to bring this governance layer broadly across your enterprise. Like, this is the big difference between sort of our approach and the more walled garden approach that you see elsewhere of, bring all your data to our system and you'll have a great time there doing AI within it. That's actually true. If you do everything within one of those kind of walled garden systems, you will have a great time. They've done a fantastic job curating those oftentimes. But modern enterprises aren't built exclusively on one of those single walled garden offerings, right? There's this sprawl of all these rando systems. The closest they ever get to standardization is kind of, or sort of uniformity is using, enforcing or recommending open standards. So this is where Kafka's sort of become the de facto standard for streaming messaging. Iceberg has clearly taken over as the kind of the lakehouse standard, right? SQL is a great de facto standard for kind of a query language. In the AI space, currently it's like MCP and A2A are the kind of the two most obviously winning standards, but that space is moving so fast. 6 months from now, those two might be fully in the rearview mirror, and there's new standards. But really, our goal is to deliver all of this sort of governance and connectivity broadly across the enterprise, on-premise, BYOC, serverless, SaaS, whatever makes sense for you, or all of these combined, meet you where you are and help bring agents everywhere within the enterprise. Because to us, that's the real end game for agents in the enterprise. They need to be able to go everywhere. And it needs to not be, oh, well, I want to write an agent on this. I guess I got to pull this data into my walled garden and run stuff on it. We want to be able to deliver it everywhere and plug everything in. So that's why we're going beyond streaming, even though streaming is a core piece of it.
Yeah. As you're talking about it, makes sense, because the very first time that one of these agents does something terrible, you're going to get the call, and you're going to have to be able to explain what that call is. Of it took data from this, it did this, and out came this. And I would say if I were a CTO or a CIO, the worst part for me was if I couldn't say what happened, because it would really kill me. Because if somebody took a screenshot and they doctored that screenshot, I'd be able to say, no, that isn't what we output. We actually output this, and I can tell you that this is exactly what we output based on that input. Or if somebody's trying to poison pill, you can actually see that progression of the poison pill. I think it's going to be really, really important. As much as governance is kind of boring, in this world, governance is going to be really key.
It is. And it's also super cool what you can do. We're trying to make it so that we can allow enterprises to insert themselves in these open protocols as well. So you got MCP servers that agents are using. Agents are speaking over MCP to make tool accesses and things. The governance layer can insert itself in that conversation and allow you to do things like say, okay, I've got this HR tool that I want to expose via MCP. The only access I have to that is basically a root level credential service agent that has access to the whole database. But I want to build an agent that allows, say Tyler to interact with his HR data. But we don't want him to be able to ask the agent, well, hey, what's Alex Gallego, my boss's salary? And so what you can do by inserting yourself in that protocol, you can say, okay, well, I'm exposing this database, but I'm going to be gating access to the specific user who you're acting on behalf of. I'm going to redact information that I don't want to flow out. So there's a demo we did at our New York Stock Exchange event where we had a set of financial transactions. And so we showed, we required the SQL engine Oxley. You can query it. Say, show me 10 transactions, and you see there's credit card data in there. Then we built up an agent that utilized that through an MCP server built into Redpanda Connect. and did the same thing and said, hey, go, show me 10 transactions, and show that what the agent showed, it just went and asked for credit cards or transactions with the credit card statements, but all it got back was hashes because our MCP server is configured to always redact credit card numbers anytime they come through and turn them into hashes. So because you have human written code designed to perform the governance features that you need, the agent's never going to see the stuff it shouldn't. It can never see credit cards by virtue of the fact that they're just never passed on. So to me, that's kind of the cool, one of the other cool features about this is this just ability to safeguard and kind of bridge the non-determinism, the unpredictability of AI agents with kind of the stability and the determinism that you need at the data governance and safeguarding layer.
And one thing that you didn't talk about, and I don't know if off the top of my head if Redpanda has this is very much a work queue, the style that we're looking at. Does Redpanda support work queues or queuing mechanisms, I should say?
I mean, you can utilize Redpanda as a work queue. I think what we do envision going forward, historically, we've been a very high performance, high scale, high throughput distributed log implementation with a Kafka API layer built on top of it. That's allowed us as a business to kind of move into that Kafka market. We see a bunch of use cases where a distributed log is a very useful building block. Kafka might not be the right API, right? I mean, you can already see this in the Kafka space itself because they've got this new queues API that's coming out, specifically kind of hitting at a different sort of way of accessing data within a distributed log. So our kind of view is that we're going to be using Redpanda as a primitive throughout this broader agentic data plane, the ADP that we're building. We're going to be using it in a bunch of places, and where it makes sense to build out functionality like work queues or things like that, we can use that as a foundation. So it's not so much. I think what we're trying to do is shift our focus away from the log as a product. Not that we don't continue to sell that, because that's super valuable in a bunch of places, but within the ADP, there's a bunch of places where the log becomes this useful primitive that enables you to build different modalities on top of it. And if it's a work queue, or if it's an audit log, or if it's kind of garbage collected contextual memory for agents that you sort of allow you to capture things and keep the amount of memory that it has over time bounded and not blow out the context window for the LLM, things like that. So we definitely foresee a bunch of utilizing the log in a bunch of different ways that aren't bound to Kafka, because Kafka is not. It's great for actually kind of a broad set of things. Clearly, given the adoption of it, but you see a bunch of people trying to figure out, okay, how do I fit my use case onto this, very partition centric Kafka API?
Well, I mean, I think this. I worked with Confluent very early on, so the very first Confluent Kafka implementations, I was consulting for them on and talking to people and trying to explain, and this is what a partition means, and this is there's some real difficulties there, some real issues there where if you don't understand that and you don't design a system, for example, Agentic, you could have all these front of line issues. You could have some basically a message that comes in at one or the other. It requires a decent amount of understanding to what you talked about before. That software engineer, not just knowing how to code, but how does this thing work behind the scenes? That's equally important.
Yeah, it bleeds a lot of the implementation through, and it's such a useful set of functionality that it's still been widely adopted and super practical, and you can use it for a lot of things. But yeah, if you don't, you have to understand those implementation details, or you can shoot yourself in the foot for sure.
Okay, so now is there any time frame or availability of this?
Yeah, so we've been working on, like, I think the way I frame it is there's kind of three core pillars here that go into effective enterprise AI. It's kind of data, AI, and governance. We've got we're pretty solid on the data space, right? Particularly in streaming, and we bought this company Oxla recently that has a high performance distributed SQL engine, And so we've added that to the portfolio. So we're pretty solid on kind of the data streaming, data querying side of the equation. On the AI side, we've been investing very heavily this year in building out AI integrations. So we have MCP server integrations, the ability to deploy MCP servers, the ability to, as I alluded to earlier, add governance features in those related to like I want to redact things or I want to have additional access controls built into it. So you can do a lot of this kind of dynamic governance within those MCP servers. And we've also started to build out a declarative agent framework. At the same time, we're building out the ability to connect external MCP servers, third-party MCP servers, or third-party agents built in other frameworks into this governance layer. Because we're under no illusions that we're going to build like the be-all to end-all agent framework or the be-all to end-all. There's just so many startups out there. There's so many people working on this. There's always going to be frameworks that just do amazing things. People want to use those frameworks. We need to build as with everything else we do, meet our customers where they are and say, you've built your agents using LangChain or whatever framework you want to use. Fine, you can plug those in and use them here as well. So, but we've been kind of building out that core of integrations. And then the last part is kind of layering the governance on top. One of the key pieces of the governance story is BYOC, and there's a really non-trivial thing to build. We already have that, so that's fantastic. So that gives us the kind of the sovereignty piece of like I want to have my AI agents and I want them managed and run and I want it done within my private network, so that my data never leaves our network. I never go out to some external LLM that I don't know what the heck it's doing, under the covers. I can run my own sandboxed, open source LLM here or with some provider like our partner Poolside. BYOC is like a key part of the foundation of the governance story. And then there's all the other stuff around auditing and lineage and access controls and things like that we're actively building out. A lot of that, short of the access control piece, you can actually do pretty effectively today using the primitives we have, but we're building out additional features that kind of just make it happen naturally so that everything you do in the system is audited by default. You have simple ways to query that. You have observability built in, and it's through OTel, so you can plug it into whatever observability system you're using, these sorts of things. So that's kind of the broad vision of how we're delivering it. I would say as of today, the data stuff is solid. The AI stuff, we have the MCP stuff is ready to use. The agent stuff is kind of in an early sort of beta scenario. So we're actively working with kind of early design partner customers, and we're looking at having kind of more of a broader public launch sometime early next year, I think. But anybody who's interested in trying this stuff out should definitely reach out. And we are working with customers now, and we've got bits that you can use and play with. And some of it's in the open source as well. Like a lot of the MCP stuff is in Redpanda Connect, so you can actually download it and try it if you'd like. But so we're kind of at that part of the early preview in customers' hands, but not generally available yet. But give us a few months.
I didn't mention it specifically as I went through your storied career, but you were promoted. You started, as you mentioned, at Isilon at the bottom of the bottom, and you worked your way up. You became software engineer. By the time you left Google, you were a senior staff engineer. I think I remember you were talking about putting your package together, and you'd spent just tons and tons of time on that package to get promoted at Google. By the time you left Snowflake, you were a distinguished engineer. Now you're a CTO. What is your secret for getting promoted?
I think at the end of the day, for anybody, in these sort of corporate career ladders looking to get promoted, the crux of it is get shit done, like get important stuff done. And the trick is, how do you do that over time? Like if you look at Google's career ladder, like I like Google's career ladder. I think it's well laid out. It's reasonably well understood across the industry. A lot of companies kind of copy it or mimic it. So when I started at Google, I was an L3, which is their software. I don't remember the name at this point. I was an L3 engineer. By the time I left Snowflake, I was a Google equivalent L9. So from 3 up through 9, kind of walked through that that progression. The beginning portions of the career ladders for these companies. So for Google, it's kind of mapping L3 through 5, I would say, or and below 2. Like there's 1 and 2. Those tend to be at Google. Those tend to be kind of more interns or that kind of a thing. But so L1 through 5 in the Google parlance is basically focused on what can you deliver, as an engineer yourself. And the key thing to do, I think, in all of those stages is look and be like, well, what is it that's needed of me? What should I be doing to deliver things well? Is it, going from L3 to L4 is often like looking at I need to be more independent. I'm not necessarily doing all the design myself, but I'm able to execute on design, participate in them, and deliver stuff consistently. Going from L4 to L5 is usually more independence around the design. You're doing the design work yourself, and there's some amount of leadership around that. But it's always been kind of a matter. It's this intersection of like, what do I want to do? What am I good at? And what do we need to get done? And how can I fill a gap that's not being filled elsewhere? I always kind of try to go where there's a vacuum of effort being put in on a problem that needs to be solved. And that's a good way to deliver useful impact without having to sort of try to crowd others out or be in a crowded space. That's not to say that you can't, go somewhere where there's a lot of people doing cool things. Like I've been fortunate to work in streaming, for the last nearly 20 years, and it's become a very popular and competitive space. But you can always kind of find room to collaborate and work on things. But it does mean like figure out what you're good at, figure out what you'd love to do, because that really helps you be motivated. Find important hard problems to solve and solve them there. And up through L5, it's all very individual contribution focused. And then beyond that, so up, kind of the levels beyond that, I feel like there's then a big shift that it goes from like your individual contributions to a mix of your individual contributions, but also how are you enabling and helping drive efforts across increasingly large scopes with increasingly large impact. First smaller teams, then kind of larger teams, or maybe a few smaller teams, then groups of larger teams, industry-wide impact. The bar just kind of raises at every level, and the kinds of things you have to do shift a little bit at every level. It almost feels like a different job. And for some people that's fine. Like the things that I'm really good at. I like to say I'm a totally decent engineer. I'm very good at being an engineer. I am not remotely the best engineer out there from a like delivering code perspective. There are engineers that are just, dozens times faster than me at getting stuff done. But I am very good at what I do, and I do understand systems really well, and I'm very good at learning systems. But the other piece that I bring to the table that's enabled me to kind of walk that later stage of the ladder effectively up through those larger and larger scopes is I'm very good at communicating, very good at bringing people along, encouraging collaboration, enabling teams to function effectively and deliver well, while making good technical choices along the way. And so kind of that ends up being at these larger levels, in my experience, that ends up being kind of the types of problems you need to get better at and solve. And for some people, that's just not your thing, and that's fine. Like it may be disappointing that you want to go kind of higher up in the levels, but like if you just love coding and hacking stuff out and you're really good at going deep, you absolutely can, believably get to like, level 6 and level 7. Stuff beyond that, it gets a little bit harder. You tend to see fewer people at say level 8 and level 9 who are just coding, really, just kind of in their own space. There are a few that kind of fall into that because they're just remarkably good and deep, but really there ends up being a lot more of this leadership and for these IC tracks as well, because like kind of at least at Google, right around L5, it branches into a manager track as well. It's a lot of what's the right term? There's a direct authority and indirect authority. It's a lot of indirect authority, so of course you're seen as a senior engineer, but like nobody reports to you. Like at Redpanda, I got no reports. At the same time, I am the CTO, so of course everybody sort of recognizes that I have a lot of executive authority, and what I say, you do notice as you sort of climb the ladder that people are more likely to listen to you, which just makes your job easier, which is nice. But but there is a skill to be learned on that IC track of how do you lead without explicit authority. And so it's that's kind of a long rambly answer, but that's kind of my view on it, of all the different pieces that have gone into it. But at the end of the day, it's all in service of delivering useful things.
Okay. One final question for you. You've published several papers. You published a book over time. Actually, you didn't publish a book. You just did the papers, right?
No, I did the book too.
Yeah. Oh, you did the book. You did streaming systems.
Yep.
Streaming systems on O'Reilly. I remember now. Okay. Why did you publish so much in your career?
It's fun. But it really started. I kind of alluded to this a little bit with the MillWheel paper that I talked about earlier. We really wanted to share it. At Google, especially back then, Google didn't do much in open source. It was, you were doing these amazing things, but no one ever saw them. They just, particularly in TI, they only saw they saw the cool products that were built on top of them, but they didn't see what you were building. So for us, it started as just a way to say, this is what we're doing. These are the cool things we've done. Share our ideas and maybe hopefully help push things forward. And it just kind of, I don't know, it's kind of addictive. It's fun. It's this good feeling of being share what you've done, get feedback on it, see what others are doing. I started doing the talks, and the book that came out of, as I said, wanting to make sure that people understood stream processing. But the papers, it's really, I've always tried to have this approach of trying to pragmatically push forward the state of the art in whatever I'm working in, and being able to publish a paper that brings something novel, whether it's an actual technical novelty, which there was some of that in the MillWheel paper, which incidentally I was not the lead author on. I would get credited as the lead author because we sorted alphabetically, but that was actually Sam McVitie was the guy who actually made that happen. That one, there was really cool technical innovations in there. The Dataflow Model paper, which I was the author of and I did push out, one could argue there's nothing new in there in as far as kind of the core ideas that are presented, but they were sort of presented in a way, and somehow in the way that we kind of packaged it all together really managed to shift the industry's view on out of order processing and stream processing, and really had a lot of rippling effects afterwards. Sometimes the novelty isn't that you've come up with a new algorithm, it's that you've figured out how to frame things and how to have a model to work with them to move forward. But I've always kind of liked to try to push forward the state of the art, and I think aiming to publish papers on that helps you kind of set a bar of well, I'd like to publish a paper. I got to make sure that I'm actually doing something that's worthy of paper publishing. And so it's a nice way to kind of motivate yourself, and it feels good for the team to be able to have your name on a paper and go to a conference and meet other people and have them be excited about what you've done and give you feedback. And so it's just, to me, it's just good hygiene. It's good. It's good health, health for the team and health for your sort of approach to your engineering to invest in papers.
Almost like good karma. Sharing.
Yeah, good karma, and it's fun, and you get to meet people and you network, and it positions wherever you're working. It positions that company as helping push forward the state of the art. It makes people more likely to want to come. But so many people apply and say, "I read one of your papers. I want to come work with you and your team." It's there's a lot of value in that.
Well, Tyler, thank you so much for coming on. I really appreciate it and sharing so openly.
Likewise, thank you for having me, Jesse. It's great to see you again.